Before explaining about big O, big theta or big omega, first I will give you some of the information or introduction about this big O, big theta and big omega. Now I have two non-negative functions called as t of n and g of n. Now t of n is actually a running time of our algorithms. That means if you design any algorithms, what is the running time of that algorithm is indicated by t of n. And one more running time is there, that is the function called as g of n. This function explains, we assume that one algorithm is there whose running time is g of n. Okay, we are comparing this g of n with our algorithm's running time of our function called as t of n. Okay, what is the meaning of big omega? Big omega of g of n is the set of all the functions with a lower or same order of growth as g of n to within a constant multiple as n goes to infinity. Now consider the g of n is actually a quadratic. Its function shows the running time is quadratic. Now if I design any algorithms within this n linear or log n or n log n, I can say that my algorithm is actually big O of g of n. That comes under big O g of n. Okay. Here it is explaining g of n is multiplied by some constant values and n value should be infinity, means a very large number, large input size. Here some examples are given here. N belongs to O n square. Here n means t of n, that is our algorithm's time, and n square is actually g of n, that is we are comparing an algorithm of n square with our algorithm here. Okay, now this is n square is larger than n, so I can say n belongs to O n square. It's a true. Here also the same concept, n square, and I am having running time is n, so it is belongs to n square. It's also true because n is less than n square. But in this case, both left hand side and right hand side have the same function. Here also n square, here also n square. Here n into n means n square, here also n square. So this is also big O actually. You may ask, sir, why I am not considering this constant value like 100, 5 or half? Why I am not considering these constant values? I will give a small example here. Now if you are going to buy a car and a bicycle. If somebody asks, where are you going? You are just telling him, I am going for buying a car, because the cost of car is very, very high than cost of bicycle. So you are neglecting the value of bicycle there. In similar way, when the constants are arrived, it's having neglectable value. We are considering only linear, quadratic, cubic, or like that one. Okay. So all these equations are actually big O. Now consider this example here. Our algorithm's running time is n cubic, and the g of n is actually n square. We cannot say n cube belongs to omega n square, because our algorithm's running time is more than the assumption running time. Similar things happens here also. Here n cube, here n square. Here n raised to 4 and here n raised to 2. Our algorithms take more time, will take more, consume more time. So it's not belonging to omega. So that is the explanation given here. Sorry, it's not a omega here, it's a big O. It's not omega, it's a big O notation here. Now, what is the meaning of big omega notation here? Big omega of g of n stands for the set of all the functions with a higher or same order of growth as g of n. Here also you have to multiply with some constant value, and the n value should be infinity. Big omega means our algorithms take more running time than the assumption algorithms running time. All the algorithms which will take more than assumption algorithm time is considered as here omega, big omega. See, if our algorithms take n cube running time and the assumption algorithm is actually n square, I can say n cube is belonging to omega n square. Here also same thing. Here n square, here also n square. Both are same. I can say it's a omega notation. Here in this case n and here n square. Our algorithms take only n linear, but assumption algorithms take more time consuming, n square. So it's not belonging to omega here. Only that set of algorithms which take more than or equal to n square, that is called as big omega. Big theta means all the algorithms, the set of all the functions that have the same order of growth as g of n, when g is actually multiplied by some constant value and n goes to infinity. Every quadratic functions a n square plus b n plus c with a is greater than 0, where the a value is greater than 0, some quadratic equations are generally theta n square here. Sorry, this is n square. Theta means you are providing upper boundary as well as lower boundary to our algorithms. If our algorithms stay within that boundary, we can say it's a theta, big theta.